Right, welcome back. Let's do question 1.4. Right, before we continue with our general solutions, I want us to remember this. For general solutions in quadrant 1, remember that our theta, so our angle theta is equal to reference angle plus k times 360 degrees, where k is an integer. Okay, so in quadrant 1, remember that. And then in quadrant 2, our theta is equal to 180 degrees minus reference angle plus k times 360 degrees, where k is an integer. And then quadrant 3, theta is equal to 180 degrees plus reference angle plus k times 360 degrees, where k is an integer. And then quadrant 4, the angle theta is equal to what? 360 degrees. Theta is equal to 360 degrees minus reference angle plus k times 360 degrees, where k is an integer. Just remember that this is almost the same as what? It's like we're getting these from the cast diagram. Remember the cast diagram? 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, the cast diagram. Right, remember here we have theta, which is our reference angle, and then here we have 180 degrees minus theta, which is 180 degrees minus our reference angle. Third quadrant, 180 degrees plus theta, which is 180 degrees plus reference angle. Then fourth quadrant of 360 degrees minus theta, which is 360 degrees minus reference angle. Just remember that. Okay, right. So we're going to use this as we find our general solutions. So we're given that 3 sine x is equal to 2 tan x. 3 sine x is equal to 2 tan x. Let's divide by, first of all, tan x is an identity. So 3 sine x is equal to 2 sine x over cos x. And then we can multiply both sides of the equation by the denominator, which is cos x. So we're going to get 3 sine x cos x is equal to 2 sine x. Okay, let's get this equation. We can factorize this, isn't it? Let's bring 2 sine x this side, so it becomes 3 sine x times cos x minus 2 sine x is equal to 0. We can factor out sine x, and then we remain with 3 cos x minus 2 is equal to 0. Therefore, sine x is equal to 0, or 3 cos x minus 2 is equal to 0. Then from this one here, we can see that this is 3 cos x is equal to 2. Cos x is equal to 2 over 3 after dividing by 3. So we have this and this. We're going to use these two to find what? Our reference angles. Let's start with sine x is equal to 0. So this is like in the first quadrant, and then our reference angle is 0. Okay, so remember we have two quadrants where sine x is positive. It is in the first quadrant and second quadrant. So its first quadrant is going to be x is equal to our reference angle, which is 0, then plus 360 degrees times k, where k is an integer. So this is just x is equal to 360 times k. where k is an integer. Okay, that's the first one. In the second quadrant, it's going to be x is equal to 180 degrees minus 0 degrees. Remember, 180 minus reference angle plus 360 times k, where k is an integer. So this becomes x is equal to 180 degrees plus 360 degrees times k, where k is an integer. Okay, that's the second one. Right, we're done with this one. Let's go to cos x is equal to 2 over 3. Let's find the reference angle. So x here is our cos 2 over 3, which is equal to, if you put in the calculator, this is 48.19 degrees. Okay, this is positive. So it's going to be positive where? In the first quadrant and fourth quadrant. Cos is positive in the first quadrant and fourth quadrant. So in the first quadrant, it's going to be x is equal to our reference angle 48.19 plus 360 degrees times k, where k is an integer. Right, that's the third equation. And then we have the fourth quadrant. It's going to be x is equal to 360 degrees. So this is degrees, 360 degrees minus 48.19 degrees plus 360 degrees times k, where k is an integer. Then 360 degrees minus 48.19 is x is equal to 311.81 degrees plus 360 degrees times k, where k is an integer. Okay, that is the fourth one. So our general solutions, we have 1, 2, 3, and 4. And then you can write them nicely. You can list them nicely here. Okay, that's what you're supposed to do there.